Hello students, welcome back. Previously we went through the logarithmic functions. We defined it as an inverse function of an exponential function. Remember? Therefore, all the rules for exponential functions, all the rules for inverse functions applied. Domain becomes range, range becomes domain. And then the cancellation rule. Inverse functions cancel each other out. X goes to y, y comes back to x, basically. So log and exponential kill each other off. Exponential and log kill each other off as long as they come right next to each other and same base. If you have two different bases and they're not inverses, so that's out of picture, of course. And then one more thing, a to the 0 power is 1. Yeah, everybody knows that. Consequently, log of 1 is 0 through this cancellation rule. 1 is a to the 0 power, and cancellation, we get 0. So we get log of 1 equals 0. And that's going to be confirmed by any kind of graph right here. Goes through 0, 1. Oh, excuse me. Exponential function goes to 0, 1. Log function goes to 1, 0, depending upon a values. Here, a value looks like a value is pretty small, so the graph is very flat. And we have symmetry with respect to y equals to x. The domain of blue is negative infinity to positive infinity, you can see that. And the range of red is negative infinity to positive infinity. The range of blue is 0 to infinity, only above the x-axis. So the domain of red is 0 to infinity, only to the right-hand side. You can see all those. And this program is randomized, so you can run it again for different a values. But same property. In this case, looks like a value is very, very close to 1, it appears. So graph is very flat. In this case, looks like a value is pretty big, so grows up very quickly. And then appropriate behavior is reflected on the graph of log functions. And then we have the other cases as well, but that's not very important. Okay, so much for review. And then we talked about natural exponential functions and natural logarithm as well. All right. Let's go to our main topic, the logarithmic rules. Here's a reminder on exponent rules. Remember all those? And it turns out that we have some parallel properties associated to the logarithm. First, we already know the cancellation rules. Those are coming from inverse functions. So exponential and log cancel each other out. Log and exponential cancel each other out. And here, and this is basically a to the 1 power. So after cancellation, we get 1. And this one here, we have a to the 0 power. So after cancellation, we get 0. So remember all these rules. And the last two rules are not too bad, because even if you forget, if you punch in the calculator, you can easily retrieve 1 and 0. But these two cancellation rules, these two you must know to the heart. Nothing should be interfering in between. So if there's a barrier, it doesn't work. And then if you have two different bases, it doesn't work. All right, next, the standard rules. And these are called standard because these really are standard. It turns out that the first log rule here, which I'm highlighting in blue, comes from this exponent rule, and second from the second rule, and then the third comes from the third rule. But exactly how they are associated, how do you prove those, I'm going to skip that part. Instead, I'm going to post an optional video I prepared for STEM algebra for interested students. I don't think there is any, but just in case. I mean, those were optional videos for even STEM students. So anyway, that's how log rules work. log of x times y is log of x plus log of y. So log changes multiplication to addition. And then this is just inverse. Division to subtraction. You see, multiplication, division, addition, subtraction, those are inverses. So they're easy to remember. If you remember the first rule, the second rule follows easily. And the third rule, well, if you just add x to the k power, that is basically adding up log of x k times. So we get that. Yeah, repeated multiplication versus repeated addition. But that's when k is whole number. If k is a fraction, for example, then this is really, really interesting because you have square root, cubic root, radical, and we just have 1 over n times log. So the right-hand side computation becomes much, much, much easier. And that's one of the main purposes of logarithm, developed in, I think, 10th century. People had really humongous numbers to deal with, and division was a very, very difficult computation. You have to do some long division. And radical computation was, really, really hard. But logarithm solved all those problems because division became subtraction and radical became just a multiplication by a simple fraction. By the way, a warning, these are just, these down here are just natural log version. So A is equal to E. Now warning is right here. Log plus log is not equal to log of x plus y. So log does not separate addition. Log plus log works for log x times y. Also, log times log is not equal to log x times y. I haven't seen many students making this mistake, but I do see a lot of mistake for this one. If you have log x plus y, you cannot separate because this quantity on the right hand side is log of x times y, not x plus y. So this rule here, this one here, please remember, warning, don't make this mistake. I see this mistake a lot, to tell the truth. As for the proof, no, I'm not going to bother. That's way too much for this course. Let's see. This, and then let me reproduce that warning here. Okay, the final log rule is the change of base rules and goes like this. Any arbitrary based a to the x power can be converted into natural exponential like this. There are so many exponents, so bigger font is in order. Yeah, okay, that's better. You can read it better. E to the x log of a. And log base a of x can be rewritten as natural log of x or natural log of a. So you can rewrite arbitrary logs into natural logarithms. You can rewrite arbitrary exponential into natural exponential through these conversion formulas. If you pick up your calculator, then if it is cheap calculator, it'll have natural log. You may have to do some second floor computation, but there should be ln. So if you have to calculate, for example, something like log base 3 of 14, for example, then you can convert it as log of 14, natural log of 14 over natural log of 3, and then punch in the calculator, natural log of 14 over ln of 3, and then do your computation, you're going to get the answer. Good calculators nowadays support this log arbitrary base directly, but some old calculators do not support those. And if I remember correctly, TI-82 series will not support arbitrary log, so you'll have to do this computation. TI-84, I think, will support arbitrary logarithm. I'm not completely sure. Anyway, these change of base formulas are quite useful in terms of theoretical foundation. you don't really have to study and do everything about you don't really have to study and establish all the theories associated to arbitrary exponentials and arbitrary logarithm of base A. All you have to do is to study and establish the theory of natural exponential and natural logarithm, and then apply the conversion formula, and that's it. That's how you get everything else. And this is the reason that 90% of the time we study natural logarithms only. Excuse me, did I say 90%? In this course, more than half, but I wouldn't say 90%. But if you go to calculus, really, I'm not kidding, 90% or 99% of the time, you just do natural exponential and natural logarithm. The reason? Because of this. But here, in this course, it serves as a computational purpose, but not much more than that. And the real key piece are these three: blue, red, green. These. Log of x times y is log of x plus log of y. Log of x divided by y is log of x minus log of y. And finally, log of x to the k power is k times log of x. These three rules. Those three are real keys. Remember the cancellation rules. And then these two, and you're not going to forget these two because you can easily reproduce these with calculators. And then two warnings, especially this one. I guess that's it for log rules here. The use of log rules, the bulk of the applications are diverted to next week. So we're going to talk about those next week. And at that time, we'll have to review some of these again. For now, that'll have to do.